Is a set of Google slides. So if you follow the Twitter feed for the conference, you'll see the link to those Google slides. They're open for you to edit. So if you're ready to subvert my talk, this is the moment to get in there. And let me just get to that presentation. That's not it. Well, you'd think it would stand out a bit, wouldn't you? There it is, that'll do. And so I understand from Torsten and from actually bothering to read the notes for the conference that he won't introduce me. So I better quickly say who I am. My name is Richard Millwood, as you know. I've been an educator all my life. I started in 1976 teaching mathematics and computer studies. But then in 1980 I changed into somebody who wrote simulations for education, for children to learn things through running simulations. To give you a sense of scope, one simulation would be about photosynthesis, another one would be about running a United Kingdom Atomic Energy Authority nuclear plant. Although in that case, they said to us, you may not let it blow up. The safety mechanisms will kick in, which is very disappointing for a child. You know, what's the point of a simulation unless you can break it and make a mess, you know? Anyway, that took me to 1990, and then like a tidal wave, the internet hit, multimedia hit, and I spent the next couple of decades working in that kind of area in education. And what happened, of course, in the late noughties was a resurgence of interest in teaching programming again, certainly in the UK. And I was looking for something new as a challenge, and I went back, in a sense, to my old days and said, I'll get back into that again. So I spent the last few years at Trinity College in Dublin, and the research I've been doing there has been around how do I teach programming better? What are the issues around that? And that's why I'm talking about mental models today. Before I go on, I note that the chess timer is running madly, and you haven't even raised a hand yet. So I'm going to make you take time on the chess timer by saying, could you raise your hand? Does this count? Can you raise your hand if you have an educational background and knowledge? In other words, you are an academic in the world of schooling and pedagogy and those things. So I have, how many seconds do I get for that? 3 people put their hands up. And are the rest of you essentially professionals in the computing world, or academics? I'll do it in 2 parts. Professionals in the computing world? You can be both of these things, of course. And are you academics in the computing world? A couple of those, yeah? And are there any others that didn't fit into any of those categories? Wow, that was lucky for me, wasn't it, to get that right? Okay. I've never been to this conference before or anything like it. And I'm used to people in the audience being educators and academics and interested in papers and those kinds of things. So I'll do my best. So those things at the bottom right of the screen are projects I'm currently involved in. I'm doing a project called Our Kids Code, which is about getting families to do creative computing together, parents with children. This is not unknown. It's in the world at large. You'll find other people doing the same kind of thing. But it's pretty unknown in Ireland, where I'm working. And it's dead exciting. It's wonderful to see the parents suddenly see what children can do, and the children who value their parents' input. Can you believe that? How many of you are parents? Get the timer going. So you might know this, but it's not obvious that parents value you. Children value you, rather, as a parent. They're quite critical and sassy a bit. But we found in our research that children love working with their family. They love working with their parents and their brothers and sisters, indeed, surprisingly. Because they've got a focus, they've got something creative to do. So that's one project. C-Twins was about getting teachers to learn about programming by pair programming, essentially. I'd say not full-on professional norms for pair programming, but if you understand the idea, they would be on the same code together, sharing the work. And the delightful thing about that program was we had a teacher from the south of Ireland working with a teacher from the north. So there was a kind of comparative thing going on about education systems, because as you know, the north of Ireland is quite different in its education system to the south. And then the turtle stitching is what you see going on in the picture. This has been the most joyous thing in my life for the last few years. Buying an embroidery machine that can accept the output of a computer program and stitch it. Simple, isn't it? And I can't tell you what fun it brings to life to be able to do that. It also led me into some really interesting pedagogical questions which led to the talk I'm doing today. And I'll give you the very quick story. If I'm worried about this time, I think. But I'm going to give you the quick story. I went to a conference with Cynthia in Boston, and I was challenged to make it simpler to draw a leaf and fill in the leaf with thread in embroidery, yeah? So to somehow shade it in. And I'd seen a solution that was complicated but did the job, which used trigonometry. Okay? And I thought, well, can I do that better? Can I make it simpler somehow? It doesn't sound like a very complicated task. So I applied the thinking of Seymour Papert. So here's another chance to... Oh, thank you. Another chance to ask the audience. Yeah, I know, I should go back and deal with that, but I'm talking at the moment. You don't need to see my picture, do you? Of the embroidery, I mean. So, I was going to do an audience question. Seymour Papert, who knows Seymour Papert? Has heard of him? Yeah? And do you know that Cynthia's in the audience with us? I've got to tag you, Cynthia. Cynthia is Seymour's colleague, and she's speaking tomorrow, keynote speech, which you must go to. And they invented this logo together with others, and developed thinking around children's learning. And a crucial part of that, to me, is the way that the language they developed allowed children to think about their bodily self and their bodily movements as a source of thinking about the program they're writing. So they invented turtle geometry, the idea that you move forward, turn right. You've all seen this, haven't you, with children's toys? Maybe some of you have programmed it in Logo, have you? And the modern way of doing that is to use Scratch or Snap, or, you can't see it anymore, or Turtle Stitch, which was the program that I used for the embroidery. They all have the same familiar background of the idea of an object that you can think with and move around, at least on the screen, and of course with the embroidery, actually on the material. So I thought about this, and I thought, what I could do these days is I could have 3 turtles. And 3 turtles will solve this problem really readily. I'll make one go round in an arc round one side of the leaf, and at the same time, another one going round an arc on the left-hand side. All right? That's the 2 turtles just doing a simple arc. And doing an arc is fairly straightforward. You move a bit, you turn a bit, you move a bit, you turn a bit, you move a bit, you turn a bit. And if you're sensible, you put that in a loop. What did the 3rd turtle do you think? Very good, yeah, see, these guys are good. The 3rd turtle went from 1st to 2nd turtle back and forward as they were moving. And as a result, that one turtle was the one that was meant to do the stitching and would fill in the space. The other 2 turtles would do nothing with the stitching, they were just there to guide the 3rd one. Now that was an elegant solution because it didn't involve trigonometry and maths. It involved something body-centered and thinking that children could enact like I just did in the room if they wished to, if they were a bit puzzled about had they got the logic of the program right. And that's a very important thing. They're building on their capacity to think, their problem-solving capacity. So I was proud as punch of this solution, and I went to see the person who'd written the trigonometric one, and I said, look, here it is. And she turned to me and said, Richard, in Turtle Stitch you've only got 1 turtle. And it was like a put down of magnificent proportions, and it led to me thinking the way I'm thinking today. So what is it about these different environments for programming that lends themselves better to problem solving and programming and learning about programming? I had become familiar with the notion that I could have multiple turtles, and I was using Scratch or Snap to do it. I don't know if you know those things. And as a result, nobody's stopping me. Are they supposed to stop me? I'm going to get my slides back up now then. Has anybody found the Google Slides? Yeah? So have you put anything in there yet? So this is the abstract I wrote for today, and I thought I'd pause at this moment and say to you, questions of clarification. Are there any terms I use, words I use, phrases I use that you don't get and you'd like me to tell you? Switch that clock.
So no clarification, but I'm very much interested in the critiques.
You're very interested in?
In the last sentence, the critiques of the design of the interactive development environment.
We can imagine my feelings when my friend told me, that's no good, you've only got one turtle. How grumpy I was that the person who had made Turtle Stitch had taken out the other turtles and I didn't know. Up to that point, I had no reason to use more than one turtle in that environment, so I didn't think it was a problem. Turtle Stitch is derived from Snap, which is the one I knew, and Snap is derived from Scratch, and you could argue Scratch is derived from Logo, and they all have a kind of family background in that.
Hi, I have a question. I don't understand notional machine.
Notional machine, is that new to you as an idea?
Yeah.
I got told off for tweeting about this the other day by a group that were meeting in Germany to discuss notional machine. Because I said to them, isn't notional machine something we have in our head to enable us to think how the computer works? And in my case, I call that a mental model. So in other words, when I read a computer program, I look at the steps and I execute them in my head somehow. And that model of the computer in my head, of course, is nothing like the real physical artifact. It's an abstraction, it's simpler, it may be wrong indeed, very often is wrong, and then I get into mistakes. So notional machine for me was this mental model I had in my head. I was told off, no, it isn't, Richard. It's a pedagogical thing. It's something teachers tell children to help them to learn to code. I think both answers are correct, by the way. I don't know whether you agree, but do you get what that means then? When it's a pedagogical device, you're describing to children or to adults, this is how the computer works. And when you do that, you cannot talk to them about binary, you cannot talk to them about electronics, not if you're talking about a computer program they're writing. You have to simplify and make abstractions for them. So either way, whether it's a pedagogical device or a mental model, that's a notional machine. It's how the computer works. Did I answer your question? I thought you were going to ask another one, yeah.
No, I would have just jumped into the conversation about notional machines.
Oh, please do, yeah.
And so the difference is, so the difference between the 2 points of view is like, who is it for? So from the perspective of the learner, there's no difference between the mental model and the notional machine. From the perspective of the teacher, the notional machine is the tool with which the teacher hopes to raise a sort or generate a certain mental model, and then, but it's useful from that perspective. So depending on how you look at the problem.
Yes, I think you're right. But what I'm going to do is I'm going to play this chess timer thing to the nth degree. Turn to the person next to you, or if there's three of you on a row, like here, come a little bit closer and talk together. Can you share for a few minutes with each other what your idea in the computer is of a variable? How do you conceptualize it? How would you describe it to somebody else? Could you do that? Because that's part of the notional machine. And that might get you going on trying to think how you, in your head, have a notional machine. So please sit together and have a chat about that for a few minutes. Otherwise I'm never going to catch up. I don't know which one I am actually. Which one am I?
You're the speaker here.
So I've had 11 minutes, have I?
No, you have 11 minutes left.
All right, and they have 15 minutes left. Oh, good. I'll run them down a bit then. Thank you. Can I help either of you guys? Deep in thought? That's fine. I just didn't want you to feel lonely. Is this your first go at chairing this kind of chess time? Is this no, you've done it before?
Of course.
Yeah, I don't know. It's new to me.
No worries, no worries.
Yeah.
I did it all the years, and it was rather nice. Sometimes it's more interactive, sometimes it's not.
Yeah, sure. What one needs, of course, is strategies in your mind. So, how we're going to do this? Yeah. So, if I may stop you, and I apologize for stopping you, but you can talk again in coffee maybe, and maybe we'll get another chance to talk. Does anybody want to tell us about what they found? Did they find, I'd particularly like to hear if two of you got together and found a completely wildly different result, you know? Go on then, tell us about what you found.
I think we were having the paradigms, whether procedural or functional. I think it showed up because we have the metaphor of the shelf, although the box where you could store things. I see as a procedural. It's something really, well, it's valuable, understandable, but also I'm coming more from functional mindset. So I was thinking more as a label or a post-it. It was a name something, so you could move the label rather than storing the thing. You could change.
Did you just say move the label? Yeah.
Yeah, I mean, it's whether you move the context of the box in a procedural, you mutate the context of the box, or you move the ID to other things in a functional.
The content. Yeah.
Well, not the name. You could stick the name to all the things maybe in a functional.
So there's issues here about value and name is what I'm getting at.
Yes.
And issues about when that value moves, as I was trying to push you into a slightly negative view here. Yeah. And of course it doesn't generally move, it generally gets copied, doesn't it, and so on, you know. So there's some fascinating stuff there. And you can imagine that children very often will learn computer programming these days simply by tinkering with software. With things like Scratch, you've come across, no doubt. Have you? Hands up if you've come across Scratch. And hands up if you haven't ever. Right, so I recommend it to you. It's a children's programming language at one level, but it can be very sophisticated and worth having a look at. So, I'm sorry I was interrupting. And anybody else want to report? Anything interesting they found in that discussion? At the back there.
One of the interesting things we started talking about towards the end is the difference between how maybe in higher level languages when you assign a variable, you always reference like a concrete piece of data, whereas if you're using maybe a lower level language like C, you have a distinct notion between like is your variable being assigned to the address, like the memory address, versus the actual piece of data, and then whether or not we start talking about it like, is that the mental model you want to have where you're actually thinking about the machine and boxes and references, versus do you want to think about the higher level program structure and talking about just like a piece of data and not having to care about like, is this a reference versus a pointer and stuff like that.
Cool, right. So it's quite rich, just one little thing like that, isn't it? And I was trying to explain that children will invent their notional machines quite often. And that's what I think the reason these guys were meeting last week who told me off. They were saying, look, we're sick of all this invention. We want to actually nail how do we teach this better because it's such an issue. I don't know whether they're right or wrong, and I am paraphrasing and maybe misrepresenting them even, but they're good guys. So I'm looking forward to reading the results of their work. So any more clarification questions? I think we've got some idea of notional machine now. Is there anything else in that pile that you'd like to, any language I've used? And in some sense it is the topic of my talk, what's in there, but I forgot to say that earlier. If you want a poster of my ideas about all of the things I'm doing, you can go and find it on my blog. And these slides you've already got a reference to on the tweet feed, so you can go and find this link there if you want to. So don't write it down now. I put in empty slides for you to fill in. So this is my approach. I've never done a chess timer before. But I was thinking, if you guys have got computers in front of you and you want to, you could be putting in your ideas into these slides. You can still do that now, and you can still do that after the event. But there will come a kind of time when I'll stop looking, so you might have to email me to say, Richard, I put some new ideas in your slides. I want to pause for a moment and go back to Pestalozzi. I think that's his name. Has anybody heard that name before? So from the 1700s, 18th century, credited with having come up with what I'm about to tell you a bit about. I mean, some of this is my synthesis of his ideas and others. I start with the notion that when I'm teaching, I'm trying to establish competence in a learner. Competence might include simply explaining an idea or recalling a fact. So competence doesn't necessarily mean that industrial kind of sense of competence, but it could. It's a wholeness, it's knowledge and it's craft and it's character. It's all those things combined that lead to being able to operate very effectively in the context of work or in the world of living in general. And a big important thing for me to establish is, well, what is the performance of that competence? How can a learner show that they have competence? And in the knowledge domain, it's about answering questions. What is 3 plus 3? It's about explaining those answers. It's about predicting future states. It's about analyzing past states. And it's about reasoning over all of that. That's what knowledge performance is to me. And there may be other things too, which I've not thought to think of there. Again, all comments welcome. Craft and knowledge and character, you can see I've shown as jigsaw blocks. This is to say that these things all substantially overlap and interlock with each other. So when I say craft is about organizing and making and playing and creating and evaluating, it's probably true to say that they're mixed up with knowledge completely. So these are not separate categorizations of these activities. They're more, what's the main thing about being a craftsperson? And I'm talking to you as craftspeople in many cases, I believe, am I? Do you characterize yourselves? So this is a moment for interaction. Put your hand up if you think of yourself as a craftsperson. Fantastic, yeah. And I think one of the key things in crafting is the ability to evaluate. I put it last on the list, but to know the quality of what you've made, and is it good? Does it deserve further refinement and improvement? Have I got a really flat surface yet? A flat surface interests me because in the Industrial Revolution in England, it was the establishment of the manufacture of a truly flat surface, whatever that means truly, that led to many of the advances in both science and industry. And I won't go into the detail of that, but it interests me that that was an important aspect, and that was very much a craft capability to create that flat surface. And then on to character. Well, character, again, I'm interested in your thinking here. And since the clock is going ahead of me, I'm going to get you to turn to your neighbour and ask you can look at my character ideas. Which ones do you think the employees around you and yourself in the company you work in or the organisation you work in, what do they need for the job that you're doing? Could you have a talk with somebody next to you about that? And I'll get your answers in a minute. You may have other character things that you want to talk about. Don't take my list as exhaustive. I try and nail the character one because it's one that most people don't think about.
Yeah.
It's just not academic, is it? For that matter, the craft one isn't academic very often, sadly.
There is.
Yeah. Well, I asked earlier, and quite a number, I'd say. Yeah. More than there are academics, certainly. So, how many times does this conference run?
Once a year since it's the 5th.
Okay.
Something like the 5th.
Okay. I'm mostly here because Cynthia was invited as a keynote.
Yeah.
She said to me, Richard, are you going to this conference? I thought, well, you should. Yeah, she's quite a champion. Yeah. Otherwise, it wouldn't have crossed my mind too much.
That's good. We want to foster this.
No, no, it's a good thing. Yeah, it's a very good thing.
Bring groups together who might normally not talk to each other.
Not good enough.
Not have a chance to
yeah,
talk to each other.
yeah.
Not because they are upset, but
Okay. Again, I want to invite you to report anything you found that was interesting. Does anybody have that kind of thing from the conversation they had? And don't be shy. You might not think it's that interesting, but anyway, you've got to run your clock down if you don't.
My friend over here said important aspect of character as a PhD student is not procrastinating.
Yeah. Yeah.
Or if you do decide to procrastinate, keep it to an extent. Everything in moderation, even procrastination.
Yeah. Yeah. What feature of character do we think the opposite of procrastination, whatever that is? Is there a word for that?
Workaholic?
Workaholic.
I think procrastination is great.
Yeah.
The procrastination I did during my PhD led to a much better paper than all the ones I've done during my PhD. So, do procrastinate.
So can I suggest to you both that what's probably more important is self-awareness about procrastination. Knowing when it's working and when it's not. Knowing when it's actually leading to a bad result or leading to a good result. And that awareness, that self-awareness is quite important, I'd say. Yeah, go on, please, yeah.
Well, the thing is, if you smoke a pack of cigarettes a day, you're going to get cancer eventually. Being aware of it doesn't really help, right?
I think it's not enough on its own, yeah?
Yeah, exactly.
So there's a sense of values, isn't there? Having a value in you that says, I do need to be productive.
And actually doing something about it.
Yeah, yeah. But the doing something is motivated by having that value strongly in your heart, is what I'm saying. Yeah, sorry.
I guess it's also useful to think about procrastination itself, like whether it's often considered as just being lazy, while often it's like dealing with complex psychological emotions and like understanding why you procrastinate and what environment you work in.
Okay, we'll take the other two before I...
So it's interesting to, so in the literature like child psychology, boredom is an essential thing because it's the root of creativity. But as we go into production, right, boredom is seen as waste, and then we wonder why the solutions we create might not be so creative.
Okay. Cool. Yep.
Just to return to the procrastination, isn't procrastination an important tactic in problem solving? Sometimes your plan-orientated part, the frontal part of the brain, can't deal with kind of longitudinal like connection finding, and like sometimes ignoring the problem for some period of time allows the kind of like the longitudinal parts of the brain to make those far-reaching connections you wouldn't have made before.
Yeah.
So there's a lot of data to suggest that procrastination is actually a healthy tactic in problem solving.
Yeah. And I think it's a short step up from procrastination to deliberate kind of meditative states where you say, I'm going to stop thinking about this deliberately to let my mind rest on the idea. And that's what I kind of meant by self-awareness. Once you know about these kinds of things, you can then manage your time better and more wisely, I think.
Yeah, Rich Hickey calls it hammock-driven development.
Okay, very good. So, I really wanted to pay attention to that because I don't think character in relation to craft and knowledge is taught or examined in the same way. There's a kind of assumption it's just going to happen, or maybe it's just fixed. You can't change your character. Do you have that problem? Have you ever changed your character in a substantial way, do you think? Anyway, do you want to speak? This is the whole chess time thing, and I'm just...
I'm just thinking back to my school days. One thing I kind of learned after school is that there are a bunch of, I would say, advantageous social and sort of, I guess, character skills which are learnable things. Some people inherently, like many domains, may be better or worse at them. But I think kind of if I were to go back and change my school curriculum, there's definitely some things like, say, empathy, for example, which is, you could have taught me more at school rather than just kind of hoping that I picked it up. So yeah, that's I think quite a lesson I had after school.
Yeah. So I don't think teachers are blind to the ideas that we're talking about. Indeed, in modern education, there's a lot of attention being paid to it. But in the past, over the years, it really hasn't been the examinable thing. Does that make sense? So assessing these things is hard work, and that's part of the problem. But that's why I was interested in the performance of character. And it seems to me that doing those things is an important thing, and evidencing that you can do those things. I'm going to move on, because what must I learn in that case is an interesting question. Well, I think for knowledge, the three things you need to learn are facts. Everybody knows that. Mental models, which is the key to this whole talk. And strategies, which are more about the idea of what do I do as a process to go through something, including strategies that might be in switching off and so on. In craft, what I need to learn is skills. And the skills come through practice. And practice is a vital component. So you get this kind of funny debate in education about rote learning versus creative work. I'm confused personally. I think it really matters to do a bit of both. But not because somebody else told you to do it, but because you want to do it. And that's why the character thing comes in. And in learning, yes, I need to learn about my emotions, I need to learn about my attitudes, I need to learn about values. Values is the kind of driver, I think, to avoid procrastination as a bad thing, because I really care to get the job done. And Pestalozzi, bless him, back in the 18th century, he would write about head, hand and heart. And I find that a nice, simple way to remember what I've just been talking about. Now, I had another blank slide, just in case anybody was prepared to come in and edit my presentation while I wasn't looking, but nobody's been brave enough to do that yet. So this is the key to my talk. I want to focus back on the mental models, and I think the first one, the one that matters an awful lot and is often slipped over, is the problem comprehension itself, the mental model of the problem I'm trying to solve when I write a computer program, or I plan to write a computer program. So I've learnt in my teaching to do much more, getting children to talk about and work through what the problem is itself, either through their drawing or through their speaking or their actions, and do quite a lot of that before getting on to writing a computer program. And of course the question in terms of programming is, how do I represent the key aspects of the problem, the variables and the processes in it? I think there's another mental model in the programming language itself, as a language. Knowing the kinds of elements in it, how they work with each other, what data structures I've written there, what algorithms, what statements are available to map back onto the problem, because different programming languages, as you heard from my story earlier, might have different features, and I need to know what those features are. And I must maintain a clear model of what those features are if I'm to be successful and competent as a programmer, it seems to me. And then this notional machine, which we've already discussed, it's really relating the programming language to action in the computer, and understanding what that action will be, how internal states of the computer are changed through the programming language. And finally, this is a bit contentious, but I'll say it anyway, there's an area which the programming language will have domain over, some kind of control over. In the case of Logo, back in the late 60s, it was the turtle itself and it was lists of words. Those are two key microworlds, they were called. I find it very interesting this when I taught BASIC at school to children. What was the microworld for them? The answer would be probably the printer and its ability to print out letters. Yeah? And within that context of the printer, mathematics could be done and simple string processing could be done, but that's about it, you know? That's the world they had to know or have a mental model of, because that's what the notional machine could act on to make an output and make some kind of response to their problem solving. And of course the microworld or domain links back to the problem comprehension issue. Are we actually working with the right language, because it can operate with those domains? Now, for professionals, arguably, most general purpose computer languages can cover almost any domain you like. You just go and find the right library. So this isn't such an issue, but you don't start teaching children with just everything as a rule. You try and find a microworld which they can comprehend fairly readily, and that was one of the great successes of the microworld, I believe, because I'm saying this with great risk with Cynthia in the room. Great successes of Logo was to confine it to turtle geometry, or to confine it to Lisp processing with words, and not to go into every single thing that could possibly be done with a computer. Okay, and then finally, this is to come back to my friend's question in the back there. There's this question of the interactive development environment itself. How does the professional or the learner make sense of all these mental models brought together by the one user interface that allows me to do the things of managing files, compiling or running the program, inspecting the results, managing change processes, if you like, with Git or GitHub, and so on. Still more space for you guys. I've got 1 minute left, so I'm going to switch to a practical question to you all. Here is a screen.
Sorry, can I interrupt?
Oh, go, please.
I just wanted to mention something about program comprehension, because I do a lot of interviews at work, and we find that the best performing candidates, meaning the people that we decide would be a good asset to our team and we want to work with, are the ones who spend a lot of time at the start of the interview actually doing the program comprehension step. They don't dive straight into writing code, they spend the first 10 or 15 minutes actually comprehending the problem and nailing it down before they start on a solution.
Yeah. So the importance of that understanding of the problem is real, isn't it? Is that what you're arguing? Yeah. Yeah. Cynthia wants to speak, and the guy at the back.
I just want to know how you compare or think about mental models and cognitive maps.
So to answer that question effectively, I'd have to really understand what cognitive maps were. And
Unlike mental modeling, but
so I would say I didn't spend a long time on mental models per se at the beginning of this talk, because it wasn't a very academic talk. But mental models, for me at least, are very diverse in nature. I call them unknowable in my thesis, because I did a PhD which had a bit of attention to this. I feel that they don't have somehow a very confident knowledge of them, because they're in our minds, and every mind is an island to me. Yeah? All we can get from people is their explanation of their models, their description of them. One of the exercises I might have done earlier on is to say to everybody, can you please think about the number line and the way you think about numbers? Some people do imagine number lines, some people don't. And to find out about your mental models and about that simple idea of number. But I didn't do that. And is that what you meant by cognitive map, that kind of thing?
well, quoting Martin's,
Go for it.
who says students need cognitive maps of their subjects.
Yes. Yeah.
And I think that in a certain sense means when you're learning something, to have an idea of where it's going or how you apply it. So
Yes.
you have a cognitive map or a mental model of
Yeah. So
why you're doing the thing.
I definitely personally, and I'm not the world's expert on this, but I would not differentiate them. I'd simply say cognitive map is a form of mental model. It's one way in which your mind organizes knowledge and information which it needs to be able to respond to. A key thing for mental model for me, though, is what I call execution of the mental model. And I'm not being overly simplistic here. I simply mean that you can use a mental model to generate explanations that you have not come across before. So in the cognitive map of a subject, you would use it to, for example, relate two ideas in the space that you hadn't related before, but because you have a cognitive map, you can now generate a relationship between them. Okay? So mental models are always like that. They always have that ability to run in some sense of a computer program, but I don't mean them to be precise as a computer program, of course. Was there a question at the back?
Am I allowed to speak when there's 3 seconds left on our side? It was really more just a response to the gentleman over there. Just, you know, I get that sense of like mental models and thinking about stuff, and I think there's 2 types of people, right? I like to jump in and learn quickly and be able to experiment, and I don't want to think about things too much. I really want, you know, the immediate feedback of trying stuff out, and I think, you know, there's probably 2 parts to that. You know, you can overthink things, and maybe there are lots of thinkers in the world, and then there are doers in the world, and they want to kind of just get immediate feedback, and I think you were sort of starting to talk around that.
Yeah. Well, you've been taking my time, I understand, here. I don't know how that was allowed. But I can live with it because I'm a generous guy. I can only quickly say I would have taken you through this, but you don't need to. You can go and do it yourself now. This is Scratch. This is a program that I wrote to make a man jump in and out of a bath. And I circled these 4 elements to ask the question: which mental model, which part of that exposition of 5 mental models do each of these, or could each of these be identified with or connected with? And at this moment, I have got no 3 seconds. It stopped. The clock has stopped. Well, I won't take minutes because I don't think it's possible to give this proper service. But my interest has become, having identified those 5 mental models, to ask the question: why would I want to use this Scratch rather than Turtle Stitch, rather than Snap or any other programming language for that matter? And if you haven't worked it out by now, I believe that these kinds of programming languages are going to take over the world. I don't think any of you are going to be writing text-based programs in the future. That's to get you going, but I've got to stop now. Thank you. Thank you.